solving systems of equations with elimination with addition. So we've been working with systems of equations. Systems of equations are two or more. We've been working with pairs of equations that are happening simultaneously. We've already looked at a few methods of solving systems of equations, and a solution for a system is two numbers, an ordered pair that represent the variables in each of the equations. So we've looked at graphing, where we take each of the lines and we graph them, and we see where the two lines run into each other, where they are the same simultaneously. So just like if we made a table, we would see that same ordered pair appear on both tables. So we come up with that pair of numbers through a graph. We've also looked at substitution, where one of the equations is easy to solve for one of the variables. We can get a variable by itself, and then we can substitute that equation into the second equation, and then we can solve for that particular variable. So substitution. So we've got two methods of solving equations. We're going to look at a third. It's good to have a few different tricks up your sleeve when solving equations. That way, depending on what types of equations you're looking at, you can decide which method makes the most sense. So let's take a look at this particular pair of equations. I have negative 3x plus 4y equals 12, and I have 3x plus 6y equals 18. So let's think about the methods of solving equations, systems of equations that we have so far. We have graphing. So I could take each of these equations and graph them. Neither one of them is in slope-intercept form, and neither one of them is going to be very simple to get into slope-intercept form. Can we do it? Absolutely. We could totally graph these, but neither one of them is going to be very pretty. So I'd rather not graph. How about substitution? When we work with substitution, we want to get one of the variables by itself, and we want to do that rather quickly. All of these variables here, my negative 3x, my 4y, my 3x, my 6y, have a coefficient, which means I'm going to end up dividing by that coefficient, and sometimes that can be messy. So substitution doesn't really jump out at me immediately as a great plan either. So we're going to look at elimination, which really works when neither graphing nor substitution seem like your first best option. So we've got a few steps here. Let's walk through those. So the first thing for elimination, we want to have at least one pair of like terms that has opposite coefficients. Remember, the coefficient is the number in front of the variable. So if I look at these two equations, I see that I have a negative 3x and a positive 3x. Now negative 3x and positive 3x are opposites because if I add them, I will end up with 0. And this is where the elimination part of this strategy comes into play. If I add those two together, they go away. They are eliminated. So since I notice that I have two variables with opposite coefficients, I'm going to move to step 2. So the second step, we're going to add the equations to eliminate one of the variables. So I'm going to set up my equations kind of stacked vertically one on top of each other, how you're used to adding. I want to make sure that when I do this, everything kind of lines up neatly, just like when we're doing regular addition with nice constant numbers here. So my x's are stacked on top of each other. Notice my operation is stacked on top of each other here, so I'm adding. My addition is stacked. My y's are stacked on top of each other. My equal signs, they also line up. And then my constants are over here on the other side, and those line up. I want to be able to add vertically going down, so I want to make sure that things that are alike are stacked on top of each other, so I can just add right down. So now I'm going to add like you're used to adding. I'm going to give myself a big sum sign there at the bottom. Negative 3x plus positive 3x, that gives me the 0. This is what I wanted to happen. I wanted to eliminate that x so that I can then solve for y. I still need to add the rest of these though. 4y plus 6y, that gives me 10y. I bring down this equal sign, put it in the same spot in this new equation, and 12 plus 18 gives me 30. So you'll notice what I have here is an equation with just one variable, similar to what we did with substitution, that I can now solve for y and figure out half of the solution of this system of equations. So I'm going to solve for y by dividing both sides by 10, and I come up with y equals 3. We're not done yet. If you remember, we need an ordered pair here. I need a number for x, and I need a number for y. So since I have half of that, I have y, I can go back and find x. Again, very similar to what we did with substitution. So step 3, we're going to substitute the value from step 2 into one of the original equations and solve. So I'm going to go back to my two original equations. I'm going to choose one of them, choose whichever one seems the friendliest, because remember the pair of numbers that we're coming up with should work in both sets of equations. So it's not important which one you use to find my second variable, x in this particular case. So if one looks friendlier, go right ahead and use that one. I'm just going to use this first one just because it happens to be first. So I'm going to take negative 3x plus 4y equals 12. I'm going to take out the 3. I'm going to take out the y and put a 3 in its place. So here comes the y, and in comes the 3. And now I'm going to solve this for x. So I have 4 times 3 is 12. I'm going to subtract 12 from both sides. Don't let this weird you out here. 12 minus 12 is 0. That's okay to have 0 on one side. It's a little weird, but it's okay. So I have negative 3x equals 0. I still want to get the x by itself, so divide each side by negative 3, and I come up with x equals 0. So now I have a solution for y, and I have a solution for x. I'm going to wrap it up by identifying the solution as an ordered pair. Remember, if it's a word problem, we're going to end in English, but this isn't. These are kind of just generic equations. I don't know what they represent. So I'm going to end up with an ordered pair. So my final solution here, again, remember your ordered pair is x and then y, so we always write it alphabetically. So my 0 and then 3. So this is the solution for my system of equations. Remember, these are easier to check too. Feel free to take your x and y and put them back into your equations and see if they work. Let's do that. Negative 3 times 0 is 0, plus 4 times 3 is 12, 0 plus 12, that equals 12. Works in the first equation. Let's try the second equation. 3 times 0 is 0, plus 6 times 3 is 18, 0 times 0 plus 18 gives me 18. So this ordered pair works in both equations, which is what a solution in a system of equations should do.